Okay, so our last lesson of the unit is on operations with trig functions, along with some true-false practice. So what we're going to be looking at that you'll need is your unit circle, and we'll have the idea of reference angles in the back of our minds as well as something to utilize while we do these. Sorry, it might help if you can see what I'm talking about. There's our title. And so this is really just a lesson that's a bunch of examples to practice the operations as well as looking at true false. So let's go ahead and look at our first example. Cosine squared of pi over 6. So one of the first things you want to know is that when you have the squared on the inside to the function, that's the same as saying cosine of pi over 6 squared. So when we write it like this, we can now just look to our unit circle. What's the cosine of pi over 6? Well, the cosine of pi over 6 is root 3 over 2. So when we square root 3 over 2, we get 3 over 4. And that would be our simplified answer. So our second example is similar, and I want you to notice where the squared is on this one. So when we look at this one, the squared is on the number, not the function. When it's on the number, then we are actually going to square that. What is 30 squared? Well, 30 squared is 900. So what is the sine of 900? This is where we want to then look at what is 900 degrees. What would its reference angle be? So if I think about 360, how many 360s would it take? So there's one 360, so 900 minus 360 would give us 540. So then let's try another 360. 540 minus another 360 would give us 180. So that means I have 180 degrees left to go. So that means that sine of 900 is the same as sine of 180 because they are coterminal angles. So sine of 180, we go to our unit circle and we get 0. So what we're working on again today, as you can see, is more how can we simplify things that might need us to use our reference angles or coterminal angles or things like that. So our third example is 4 times the tangent of negative 3 pi over 4. So again, we want to think about where is negative 3 pi over 4. So when I think about negative 3 pi over 4, that's going to put me in this quadrant here. So what is my tangent of negative 3 pi over 4? Well, that would be on my unit circle 4 times 1, because tangents are positive in that quadrant, and I end up with negative root 2 over 2 divided by negative root 2 over 2, which is just 1. So what is 4 times 1? 4. Okay, if we look at number 4, sine of 3 pi over 2 plus tangent of pi over 7 times cotangent of pi over 7. So here's one, and I want you to star it because this one is similar to a test question that we have. So you want to make sure that you can follow how we did this one. Just like we have our order of operations for every other type of adding, subtracting, multiplying, dividing, parentheses, grouping, exponents, and all that, those still apply with our trig functions. So before we can add, we have to multiply these together. Well, tangent of pi over 7 times its reciprocal. So cotangent, we can write that as 1 over tangent. So what happens is these cross cancel, giving us a plus 1. And then we can look up what is sine of 3 pi over 2. So 3 pi over 2, if we look at our, so that's pi over 2, 2 pi over 2, 3 pi over 2. What is the sign of that quadrantal? Negative 1. So what's negative 1 plus 1? 0. So when you have something like this where you have a combination of operations, make sure that you guys are following your order of operations so that way you can simplify it correctly. Okay, let's try another one. Cosecant squared 30 minus cotangent squared 30. Okay, so again, we're going to think our unit circle and reciprocal, because this is the reciprocal of sine and this one's the reciprocal of tangent. So when I look to see what is, because this is the same as cosecant 30 squared, what is the sine of 30? 1/2. The reciprocal of 1/2 is 2, so I'd have 2 squared. This is the same as cotangent 30 squared. So when I think what is tangent of 30, it's 1 over root 3 or root 3 over 3. And so the cotangent would be just root 3. So when I look at what I have, I'll square each term and then subtract to get an answer of 1. So one thing, if you haven't done it, that I would suggest doing on your unit circle is outside the parentheses. So on your unit circle you have your parentheses like this. Outside of it, I would write the tangent. So what is, so we have root 2 over 2, root 2 over 2, so the tangent would be 1. So going around and writing your tangent values on the outside will make these go a little bit quicker. So if you don't have that done already, I would strongly urge you to do that. It'll just help you when you're going through these problems to more quickly have these values readily available. Alright, so this is pretty much what the top half of your 3-8 worksheet's going to have tomorrow. It's going to just be a bunch of operations where you might have to use coterminal angles like on number 2 to help you write it in a more simple way. You might have negative angles, so you want to think of it backwards. And you're going to also be dealing with reciprocals, so being able to identify reciprocals and what those values are. So that's the first half, top half of your worksheet tomorrow. The second half is all about true-false practice. So we have more true-false on this one. So we're going to do some practice with true-false. So our first one is going to say, does the cosine of 45 equal the cosine of negative 45? So a lot of these are going to actually end up using our either exact values or our all students take calculus to help us figure out true or false. So when I look at this, cosine of 45 is root 2 over 2. If I were to go negative 45 on my unit circle, so that's down here, negative 45, cosine's positive, so this would also be root 2 over 2, so this in fact is true. For our next one, 7 pi over 4, tangent of 7 pi over 4, does it equal negative cotangent of 7 pi over 4? No, it doesn't. No, I'm sorry, I wrote that wrong. 3 pi, not 7, 3 pi over 4. So we have to consider on this one where both of these are located. So 7 pi over 4. Let's see, 7 pi over 4 would be down here. So down here, my tangents are negative, so I'd have a -1. And then over here, cotangent of 3 pi over 4. So 3 pi over 4 would be, sorry, it should have been -3 pi over 4, sorry. It should end up being down here, which again is negative, so we'll have -1. So when I go to plug these in, does -1 equal -1? So because of the double negative, whoops, sorry, this is +1 because it's tangent. So we have the negative and then the 1 on the inside. So does -1 equal -1? Yes, so it's true. When we have exact values like that, where we actually know what the values are, we can just evaluate and see if they're equal. But you're also going to have some that look like sine of 178. Does it equal sine of 358? Whoops, it might help if I write the word sine. So it happens when I write too fast. Sine of 358. So these are obviously not exact. So this is where reference angles and all students take calculus comes into play, trying to see, are the reference angles the same, are the sines the same? So when I look at 178, 178 is over here with a reference angle of 2 degrees. Well, sines are positive in this quadrant, so I know that whatever my value is, it's going to be positive. For this one, 358 is over here with a reference angle of 2 degrees. So we have the same reference angle, so far it looks like we're okay. But then what's the value, positive or negative, of sines in this quadrant? Well, these are negative. So if we're going to get a positive outcome here and a negative outcome here, can we say they're equal? The answer is no. So we would say this is false. So when you have some that are not exact values that you can evaluate, you're going to have to rely on your reference angles being the same and the outcome of positive or negative being the same in order to answer true. Okay, we're going to do another one, number 9. Now this one, again, I want you to put a star next to it. This is similar to a test question. And this one involves the square root, and on top we'll have sine 150 plus cosine of -60 over 8 times the secant of 60. So what I see when I look at this one is that I have exact values. These are all things on my unit circle. So I'm going to go ahead and start by plugging in what I know everything is. So sine of 150 is 1/2. Cosine of -60 is also 1/2. And then on the bottom, I'll have my 8. Now secant of 60. First I think, what is cosine of 60? And I get 1/2, and I reciprocal that to be 2. So now I can just simplify what's 1/2 plus 1/2? 1. And 8 times 2 is 16. Square root, you get 1/4. So this one is similar to one that you'll have on a test in terms of the square root and needing to use your exact values to simplify. And you'll have a few of these on your assignment, on the bottom half of your assignment as well, to make sure you guys know how to do that. Okay, so for number 10, example 10, we'll have sine of pi over 2 times secant of 2 pi and then we'll have 2 cosine squared of pi over 3 on the bottom. So again, I notice I have a lot of exact values, so I can do a lot of just evaluate and then plug in their results. So sine of pi over 2, so when I look at my unit circle, the sine of pi over 2 is 1, times, and then secant of 2 pi. So that's the reciprocal of cosine. So first find the cosine of 2 pi, and the cosine of 2 pi is 1, and when I do the reciprocal of that, I get 1. On the bottom, I'm going to have 2, and then whatever this is, remember that because the squared is on the cosine, it's evaluate cosine pi over 3 and then square the result. So cosine of pi over 3, that would be 1/2, so I'm going to do 1/2 squared. So I have 1 over 2 times 1/4 after I square the 1/2, which is 1 over 1/2. 1 divided by 1/2 is 2. So again, this one was just a fraction with some reciprocals as well as some squaring that we just plug in the exact values for and then simplify using order of operations. Okay, last example, number 11. We're going back to a square root problem. 6 cosine squared of 210 degrees divided by cosecant of negative 210 degrees. So when I look at this, again, I notice I have exact values from my unit circle. So I'm going to use those. So I have my 6 times, and so I look up what is cosine of 210. Well, that's a negative root 3 over 2 value, and I'm squaring that because the squared is on the cosine, over, and then for cosecant of negative 210. So I'm going to go negative 210, and that's going to put me in which quadrant? That's going to put me up in quadrant, up here in quadrant 2. Cosecant is going to have be the reciprocal of sine, so I know I'm going to have a positive. So let's see, 210, that would put me at a sine value of 1/2, so the reciprocal of 1/2 would be 2. So now that we've got the exact values plugged in, I'm sorry, it might help if you can see that bottom part. So now that we've got the exact values plugged in based on our unit circle, we can go ahead and just use algebra and order of operations to simplify. So let's see, we'll have 6 times, and then when we square this, the negative will go away, and I'll end up with 3 over 4, and on the bottom I still have 2. So let's see, when I multiply 6 times 3, I'll end up with 18 over 4 over 2. So if we think about what this means on the inside, sorry, all of this is in the radical. 18 over 4 is 9 over 2. 9 over 2 divided by 2 over 1, that's the same as 9 divided by 2 times the reciprocal 1/2. So this ends up being inside the square root of 9 over 4. And when we square root that, we get 3 over 2, which would be our simplified answer. Okay, so this is kind of a bunch of examples that are like what you're going to see on your assignment, where it's going to be a bunch like this and the first 5 that we did that are just using your exact values to help you simplify different expressions using both positive and negative degree values. So you'll have to know both directions and what it matches up with from your unit circle. So really have that unit circle filled out, have your tangents on the outside so it helps you with knowing these values a lot quicker. And then you're also going to have on the bottom half some true false, where we're going to look to use the exact values or even reference angles, and all students take calculus sign verification to help us with things like number 8 when we don't know the exact value. So like I had said last week, we're going to have time to go over any questions from 3.7 and 3.8 on Tuesday. So what I ask is that you just try your best tomorrow in class, refer back to these. If there are questions that you have, you can, again, feel free to email me. I probably won't respond till Monday, but you can definitely email me and ask, and I'll do my best to answer via email. Or you can just wait till class on Tuesday when we'll review 3.7 and 3.8 to prepare for your quiz on the block day.